Hey everyone, good afternoon. Welcome to today's webinar. The topic is Earn Schedule Concept and Technique. My name is Chaitanya and I am working as a digital marketing team member at Whizible. And I'm thrilled to speak to you today as this is going to be really good webinar. I believe all of you must have filled out the registration form with correct information so that we can provide you with better and informative content. Today's webinar will be presented by Shailesh Joshi. Shailesh works as Senior Project Management Consultant for new product initiatives at Whizible. He is spearheading efforts for creating brand new user experience and introducing smart, intelligent features across Whizible's portfolio of project management and service automation tools. Shailesh has more than 20 years of experience in IT and management, and he is a PMI certified project management professional. Before we start, just wanted to share a housekeeping slide. This webinar is being recorded. Recording will be shared with you after the webinar concludes. If you have any questions, kindly stay tuned because at the end of the webinar, we will have a short Q&A session for which you can post your questions on the Q&A tab available to the left hand side of your screen. We will do our best to answer your questions after the webinar. For social media postings, please use our hashtag #Whizible, that is WHIZIBLE. And last but not the least, there will be a short poll survey after the webinar so you can let us know how we did. We would appreciate if you complete it. It will take less than a minute of your time. Now I request Shailesh to present the webinar. Thank you. Have a great day.
Hello everybody and welcome. Today I am going to present the concept of earn schedule and the technique of how we can use this simple concept to great advantage in day-to-day project management. So let's get started with the introduction to earn schedule. Earn schedule is an extension to earned value management. It is the fourth metric after the very commonly known measures such as planned value PV, earned value EV, and actual cost AC. Earn schedule is derived from earned value, so only the EVM data is required for computing ES. It uses time units for measuring schedule performance instead of cost units. Earn schedule was developed by Walt Lipke in 2003. The complete coverage of earn schedule is available in PMI's practice standard for EVM second edition that was released in 2011. Earn schedule was recently included in PMI's Book of Knowledge, the PMBOK 6th edition 2017. Now let us look at some important benefits of earn schedule. First benefit is ES overcomes a quirky schedule variance and schedule performance indicator, the SPI, especially in late running projects. Towards the end of the project, the schedule variance, which is equal to earned value minus planned value or EV minus PV, approaches zero, and the SPI, the performance indicator, which is equal to earned value divided by planned value or EV divided by PV, goes to unity, which implies perfect schedule performance, which is counterintuitive for projects that are finishing late. Projects that are finishing late are behind schedule, and the values of SV and SPI should not be perfect in these cases. However, earn schedule based indicators, the SV time based and SPI time based, have appropriate values and behave consistently throughout the project lifetime. Second important benefit that is derived from the first is we are able to more accurately predict completion dates for projects that are behind schedule. The third is measuring schedule performance in time units is more natural. A project is behind schedule by X number of days than Y number of dollars. So it is more natural to say a project is behind schedule in time units rather than cost unit or ahead of schedule for that matter. Now let's look at what is earn schedule. This graphic represents how we can imagine earn schedule on the standard S-curve graph. As you see here, on the x-axis we have the time, and on the y-axis we have the cost, essentially the earned value, planned value, and the actual cost. And the planned duration in this case is 18 months, and as you see, the vertical line on the chart represents the status date, which is 10 months, Earned value is the curve with the solid gray, whereas planned value is the dotted curve which extends from 0 duration to the end of project. In order to calculate ES, we need to project earned value at the status duration onto the planned value curve, and the intercept of that intersection on planned value curve is the earned value. So it gives us the earned value that should have been earned as per our planned value curve. And as you can see here, this particular project shows you that our earned value is only 6 months at the status duration of 10 months. So you can easily see here that this project is running behind schedule by 4 months. So the earned schedule in this case is 6 months. Earned schedule can be computed using a simple mathematical formula, ES equal to C plus I, where C is the number of time periods for which earned value is greater than or equal to PV, and I is the fraction of planned value increment calculated as linear interpolation. Incremental fraction can be calculated as EV minus PV at the status period divided by planned value at the next status period, or planned value at status period plus 1 minus planned value at the status period. So let's look at an example and understand it in a better fashion. The stacked bar method provides a very simple yet easy to understand method to calculate earned schedule. As you see here at the top of the screen, there is a table showing cumulative earned value and planned value. These two series of values can be plotted as stack bars. Now, in order to calculate earned schedule, we need to project a line from the top bar, which is the EV bar, onto the PV bar to get the earned schedule. And as we see here, earned schedule at the end of period number 8 can be seen as full 7 periods plus a small increment, and this increment can be calculated as percent of planned value earned during the 8th time period, and we can substitute the corresponding values in the equation, and let's see how that will work. So in this case, C, or the number of periods where earned value is more than or equal to planned value, is 7. The increment can be calculated using the simple formula, and it turns out that the value of I, or the increment, is 0.288 weeks. So the total earned schedule is C plus I, that is 7.288 weeks. So this way we can calculate earned schedule at successive time periods and plot a graph of earned schedule. Earned schedule is very useful for performance evaluation, which can be done continuously throughout the project life cycle. The first indicator is the SPI, or the schedule performance index, time based. The suffix T indicates it is different from the standard or the cost based SPI. SPI T indicates how efficiently the available time is being utilized for project work. The formula to calculate SPI T is earned schedule divided by actual time, ES divided by AT. It is a measure of time-based schedule efficiency. When SPI T is greater than or equal to 1, project condition or performance is favorable and efficient. When SPI T is less than 1, it indicates unfavorable schedule performance. SPI T values can be calculated using the simple formula ES divided by AT and can be plotted on a graph. In this particular sample, we can see that SPI T value has been continuously below 1, indicating less than perfect schedule performance or even poor schedule performance, because peak efficiency of 95% was achieved in period 3, and afterwards it continuously fell to end the project with about 80% efficiency, or 0.8 value for SPI T. Here is comparison of SPI T versus the classic SPI, or the cost based SPI, and here you can clearly see that earned schedule based SPI overcomes the quirky nature of cost based SPI. Cost based SPI, or the orange curve here, starts to approach rapidly towards the unity as we move beyond time period number 10. The reason for that is earned value keeps on increasing, whereas planned value remains same beyond the planned schedule, beyond the planned duration. So SPI automatically keeps on increasing towards end of the project and becomes unity or one at the end of the project, which is quite contradictory in case of projects running late. Compared to that, when we look at the SPI cumulative based on earned schedule, it shows consistent behavior and it ends with value of 0.8, giving the true picture of schedule performance. Schedule variance or SV time based can be calculated in a similar fashion using the simple formula ES minus AT and can be viewed on a chart. And as you see here, we finished the project at the end of time period 15 and exceeded the original planned duration of 12 weeks. So the SVT at the end of project is minus 3 weeks, indicating negative schedule variance and performance. Second important application of earned schedule is forecasting, and the indicator that is used for predicting completion dates is called the IEAC or Independent Estimate at Completion Time Based. The formula for IEAC time based is planned duration divided by SPIT, where PD is the planned duration in time units. The second way to calculate IEAC is actual time plus difference between planned duration and earned schedule divided by performance factor T. The PFT, which is the performance factor, allows project manager to predict completion time more accurately. PFT can be customized based on various environmental factors and project team performance. When PF or the performance factor is equal to SPIT, equation 2 is equivalent to equation 1. Because here we are saying that the current project performance is likely to continue. IECD or independent estimate for project completion date can be easily found using the IEAC by just adding the value of IEACT calculated above to project start date. IEAC can be plotted on the chart, and here we are able to perform a few more interesting things, such as adding trend lines, doing trend analysis to get early indications of completion time. As you see here, early trend line at period number 2 predicts the estimated time of completion of about 15 weeks or a delay of 3 weeks, whereas intermediate trend line created at period number 6 projects to a duration of about 16 weeks or delay of 4 weeks. The second indicator that is commonly used coupled with forecasting is TSPI or to complete schedule performance index. This is similar to the TCPI matrix, to complete performance index, used in classic EVM. TSPI forecasts future performance required to bring schedule back on track, especially for projects that are behind schedule. TSPI equal to PD minus ES divided by PD minus AT. Second way to calculate TSPI is TSPI equal to PD minus ES divided by ED minus AT. So the only difference between the two here is using estimated duration instead of planned duration if estimate has been revised by the project manager at any point of time during the project life cycle. Value of TSPI more than 1 indicates project team needs to work harder to utilize remaining time on the project. TSPI value less than 1 indicates even a bit below par performance may achieve the target schedule. According to PMI, based on research, when TSPI value is more than 1.1, the projected duration or the planned duration is not likely to be achievable. As long as TSPI is less than 1.1 or performance improvement required is less than 10%, schedule delay may be recoverable if timely and corrective actions are planned. In our sample set of values, after plotting TSPI, we can see clearly that at the end of period number 6, TSPI is 1.09. It looks extremely difficult or impossible to achieve the original schedule of 12 weeks. Project manager has few options here. Having the project team work at close to 110% efficiency, which is 10% more than what the team is doing at that point for the remaining time. For example, doing a 9-hour task in 8 hours, or re-estimating and rebaselining to increase project duration, which will also increase cost. The project manager needs to evaluate these conflicting requirements and balance what is required Whizible project management tool has complete support for earned schedule. EVM data such as PV, EV and AC can be imported or recorded to get deeper insights into the health of the project. Whizible's upcoming release includes EVM and ES analytics tool, periodic and cumulative earned schedule, schedule variance, time based, SPIT and TSPI, IEAC and IECD, and all these charts are available for periodic monitoring and reporting for the project manager. PM can see trends in the estimated completion date and cost and decide when rebaselining may be appropriate. Coming to the conclusion, ES analysis can be used as a top-down approach to identify and evaluate adverse variances with the aim of taking timely corrective actions and should form basis for further analysis. Earned schedule is a great addition to the repertoire of project managers' tools and techniques. At the same time, project manager should be aware that ES measures and metrics are based on historic schedule performance, and past project performance may or may not continue in the future. That brings us to the end of this webinar about the introduction and use of earned schedule, how to calculate earned schedule using simple techniques and use different metrics and indicators and charts for project performance evaluation and forecasting. I hope you liked this presentation. Please let us know how we did, and we'll keep bringing more informative content for you in the future. Thank you.